Assalamualaikum and hello everyone. In this video, we will learn how to sketch the free body diagram. So what do you mean by free body diagram? Free body diagram is a force diagram that shows all the elements in the diagram. We have the force, and force is also a vector where we have the components and also the angle. And then we have, and it's drawn in an axis to show the direction of the object. Okay, we will go to a few examples in this video. Okay, look for example 1. A book is at rest on a table. So here, the book is the object in this case. So normally we will represent the object with a tiny little dot, but some may refer the object to be a box. So it is up to you whether you want to use a box or a little tiny dot. But in this video, I will use a tiny dot to represent the object. So, so for whatever object, we must have a force pointing downward, which we call as a gravitational force. And in this case, the book is rest on the table. It's not going inside the table. So it means that there must be another force opposite the direction of the gravitational force. So this one we call as a normal force. And also we know that the book is rest on the table, is not going inside the table, or is not floating above the table. So it means that we have the same magnitude or the same value of force. So if let's say I say that maybe the gravitational force is 5G, 5G, or maybe 5 Newton, so the normal force is also 5 Newton. Okay, we look at example number 2. Now we have a box on a table. A rightward force is applied to the box to move it across the table with rightward acceleration. So we a rightward force. So now the object is the box. So we put a dot here, and we know that there must be a gravitational force. And also we have a normal force. But the difference now here is that we have a rightward force. So it means that we have an applied force here. So we represent it with a F. And this box is on a table, so it means that it's on a surface. So we know that the surface can be a rough surface or maybe a smooth surface. In this example, it doesn't mention is it a rough or a smooth surface, so we assume it is a rough surface. So when there is a rough surface, then we have a frictional force. Okay, another second information given is it is moving with the rightward acceleration. Okay, the acceleration means that there is a velocity changes. So when there is a velocity changes means the force is unbalanced between F and also the frictional force. So it means that the box here, if let's say it is moving, it is using a rightward force. Okay, so it is moving to the right. So F should be, the magnitude of S is bigger than the frictional force. Okay, so you can just draw the frictional force with a less length compared to F. Okay, we look at example 3. Is quite similar to example 2, But the only thing is a box on the table is moving towards the right with a constant velocity. So it means here there is no acceleration. So when we draw the free body diagram, it's still the same, where we have the gravitational force. You can just use the gravitational force with W. Okay, W mg, or some use Fg to represent the gravity. And then for the normal force, we can use N. And then it is moving toward the right, so it means that we don't have the acceleration, but it is moving to the right, so we have a force here. But at the same time, it is a constant velocity, so it means that we have a friction here. Okay, so the apply here, F is equal to F. This is according to Newton's first law. Okay, so the right in constant velocity. Okay, so we have this. The applied force would be equal to the frictional force, means that the net force is equal to 0. Okay, we move on to the example 4. Now we have two blocks. A of mass 10 kg, B of mass 30 kg are side by side and in contact with each other. They are pushed along a smooth floor. So it means that here, the keyword here is move. So it means that we don't have any frictional force. Okay, so we don't have any frictional force, but we have F of magnitude 200 newtons. So this one is applied to A. Okay, so in this question, it depends on the question whether you want to assume this is one system or you need to separate box A and box B. So if let's say you want to separate box A and box B, so you have another force between here, the contact force. But in this example, I just want to show you, if let's say we want to, maybe the question asks you to find the acceleration, or maybe to find the acceleration or maybe the distance, or whatsoever question, and we just need to assume A and B as one system. So you can use A and B also as one system. So here, let's say we have the A and B. A and B is, if let's say the gravitational formula is W equal to mg, where m is referring to the mass. So the mass can be combined. So we have 40g here. G here is referring to the gravity, which is 40 times 9.81. Okay, so we'll get the answer in Newton. Okay, so this is the gravitational force. And then we have the normal force. The normal force, because this two box remains on the surface, so the the normal force will also be 40g. Okay, and then we have F, which is 200 Newton. But here, as I mentioned, that we don't have any frictional force, so it means that we don't have any force here. Okay, so this is the this is the answer, the free body diagram for example 4. And here the air resistance is ignored. If let's say it is not ignored, then it would be somewhere here. It will be at the opposite direction with the applied force too. But normally we will ignore the air resistance because it is, should be not F, but maybe just air resistance, something like that. Okay, because it is very small, so normally we will ignore in the question. Okay, now one interesting example is it is not moving to the right or to the left, so it is moving vertically. Okay, a skydiver is descending with constant velocity, so we have a constant velocity here. So for the first one is the object, so the object would be the skydiver. So skydiver must have a gravitational force. And also it is a constant velocity. In this case, we don't have any frictional force, but we have a air resistance. Okay, so the net force here would be 0. Example 6. An rock is free falling from a cliff. So the keyword free falling here means that there exists an acceleration. So same goes with the previous example where we have a rock. So means that we have a gravitational force. And also we will have a air resistance. But now in this question we have acceleration. So if let's say we have acceleration means that here the gravitational force is larger than the air resistance. So we have more force here compared to the air resistance. That's why the rock have an acceleration. Okay, example 7. A 0.75 kilogram block at rest was pushed by a force of 50 Newton at an angle of 30 degrees to the horizontal on a frictional surface. So let's say we have the object here, the block, and also we have gravitational force. So here because it is mentioned 50 Newton, 0.75 kilogram. So the formula is mg, so we can just substitute. The mass is 0.75. Mass will always be in kilogram. And then we have gravity 9.81. Okay, so the answer would be in Newton. So this is the gravitational force. And the gravity and there must always be a normal force here. So the normal force here, we can just represent with an n. So n is also 0.5 g. Okay, now we have applied force. So the force here is 50 Newton. So if you can see here that the force would be here, if let's say we draw an axis on the diagram here, so it will go here at the fourth quadrant. So we will have the fourth quadrant here, and then if let's say this is 30, so this will be also be 30. So we have 30 degree here, and then we have 15 Newton. Okay, and then how about the surface? Here it is mentioned it is a frictionless surface, so we don't have any friction force. So just so this is the free body diagram for example 7. Okay, example 8. A box is dragged across the floor with a rope. So we know that one of the force that exists because of the rope is the tensional force. So again, we have the gravitational force. Okay, I will just use W to represent the gravitational force. And then I will use normal, N as a normal force. And then we have a tensional force to represent the rope. If let's say you are given an angle here, then you can just put an angle here. And how about the surface? Do we have a frictional force here? So it is not mentioned whether it is a smooth or rough surface. So normally we can say that the frictional force will always exist. Okay, even for in any floor. Okay, but if let's say the question mentions smooth surface, then maybe you can just put 0.